some kanang kuan problems in electrical circuits. So we're going to use these kuan two methods, the kanang Kirchhoff's law and the Maxwell method. So familiar na ba mo ani?
So now we can solve
Na ba may ingon ani sa inyo senior high?
the T4 since naantay ko yun.
Basic EE. Na mo rin basic EE. Oh. Naramday mo di. So hanas na mo ani. Ano po siguro. Okay, so nalaman mo yung knowledge kay murag gini murag naulhin mo in your physics supposedly summer man tani. So kanang kuan anyways para di lang po makuratan ini nga kuan nga subject po ato topic karon. So this is just a review na lang kay naramday mo ani sa inyong kuan basic electrical engineering na subject. So again, just a review for kanang Kirchhoff's law. So nanan siya duha ka kuan. Nanan siya duha ka laws. The first one is for current, diba? The current law. Meaning niya ni ingan diri sa current law. The current entering the node is equal to the current exiting the node. Okay, is equal to the current exiting the node. So suppose, let's say this is our electrical circuit connection. So let's say natay connecting wire. We have a connecting wire, tas may approach aning nga node. Then in this node, may branch out siya. So nana po yung wire pa dang to. Let's say gi-connect din siya sa other resistor. And also sa usa gi-connect po sa other resistor. Let's say this is R2 and this is R1. Suppose na ay current nga may approach aning nga node. Let's say we're going to name this node as node A. Okay, node A. And take note sa mga problem sa libro, actually di nila i-define nga. Okay, di na nila i-label nga man siya ang node sa ato na pero naiuban po yung mga problems nga ila jud gi-labelan. So here, let's say we have a current that is approaching or entering this node A. Let's say this is current 1, and then napoy current nga of course mo leave ngadto ni R1, mo provide of electricity ni R1. This one is I2, and then of course napoy mo exit pa daw ni R2, that is I3. So here ang kuan para makasagot mo ani this kuan kani siya nga diagram can be also model using using the application of fluid dynamics, wherein we can model this one as a piping system. Diba sa pipe, sa water pipe, let's say we have here a pipe and then we branch out siya. Let's say this is kaning Y nga fitting. Okay, Y nga fitting. So ang pipe may branch out siya, may split ang iha flow in this direction and in this direction too. So let's say in this fitting, we can say that this fitting is similar to the node here, kaning node A. And then of course, by the principle of kanang kuan fluid mechanics, so din ang tubig. So let's say we have a volume flow rate here entering this fitting. Then of course, na-split ang tubig. So mga to siya. This is Q2 and then this one is Q3. So the same thing, diba? In analyzing kanang fluid mechanics problems, especially kaning nga tubig, of course, we all know that ang misod nga tubig, that is Q1, is just equal to megawas on the other side of the pipe, or either side of the pipe, that is Q2 plus Q3. Marabag conservation of mass. The same thing with this one, conservation of electrical charge in our kanang electric circuit. So here, balik ta sa atong electrical circuit.
plus 0.
So according to kuan sa kanang current law, based on the current law,
times the CV,
yung man siya, the current entering is equal to the current that exits the node. So therefore we can say that that is I1 based on our diagram is equal to I2
so we have
plus
the Q rejected, solving this
I3.
is
So mana siya ang sa current law, and for every node, so nagina siya ikagalingan yung mga directions depending upon kanang imong direction imong giset. Let's say basin the I3 yung direction kay pabalik. So in writing that one, of course, our equation would also change. The sign, or maybe the placement, maybe I3 would be on the left side of the equation or I1 would be on the right side of the equation. So magagara na sa imong giset nga direction, but in other problems nanay gihatag nga direction. So just follow that one. Anyways, kana siya nga direction would be true, mahimo na siyang tinuod once makuha na nimo ang value sa imong mga currents. Kay if you have a negative current, unsa may pasabot ana class, if na kay answer nga negative current, what would be its kanay kuan, unsa may pasabot ni ana with respect to its direction if you have negative answer. Okay, so sakto pabaliktad. So mana siya, dira na nimo ma-verify nga ang imong assumption is true or false sa sign sa imong answer. Okay, so mana ta sa first nga kuan, law for Kirchhoff. Ikaduha is the voltage law. Voltage law. So giingan sa voltage law, it states that the sum of all the voltages, or kanang potential difference or EMF, the sum of all the voltages in a loop is equal to what? Pila man class? Is equal to pila man? The sum of all the voltages in a loop is equal to unsa man? Based on the voltage law. K equal to 0. Equal to 0. So sakto. And if we're going to model this, let's say kanin mo datong kuan, of course our circuit, di ba? In order for our circuit to function, dapat naka-close na siya. So if naka open circuit, wala din na siyang function. So for a closed circuit, so it represents a loop. Okay, na a loop. Let's say I have here an example of a loop. Let's say this is my power source, my resistor, then this one, another resistor, and this. So this is just a basic example of a circuit wherein we have one loop. If I'm going to add another one, so we now have two loops, di ba? Duha na ka loop. So duha na ka loop area. So let's say if I'm going to label, so mag-label ta. Let's say this is node A, B, C. So kanya akong ipang label, this one represents the node E, F. And then ang mo represent ani sa loop niya is we have two loops. So ang pag-define nato sa kanang mga loops is this one. So we have here loop number 1, we have A, B, E, F. Loop number 2, so kani siya, kani ikaduha diri, that is B, C, E, D. Actually we also have the third loop. Kinsa may makaguess kung unsa ang third loop? Okay, humana man ta sa first loop, man ang first loop kani. Second, and then napay ikatulo nga loop. Makaguess mo? Unsa man ang ikatulo nga loop diri ah? Unsa man? Any idea? Nakasunod pa mo class? Unsa man? Yes, sakto. So tama. So ang entire kuan So kung ato na siya kanang superposition, actually mahanap na siya, or i-superpose, mahanap siya. Muna katulo. Ato tangtangon ang middle. So this is A, C, D, F. So muna katulo nga loop. We have A, actually you can also write B, C, D, E, F. So anyways, the same na siya. So we have 3 loops here, and according to this second law, the sum of all voltages in a loop is equal to 0. So meaning, di ba, in loop number 1, let's say I'm going to put some values here. Let's say this is R1, R2, R3, and of course this is E. Again, E represents the voltage of our power source. Now, for our power source, of course, nagana siya kanang voltage dira. Let's say a battery. So, if this is our direction, again, in analyzing kanang Kirchhoff's, dapat kay baka sa mga direction sa currents dira. Okay, sa pag-analyze nimo. So here, in analyzing, if ang direction sa imong current, let's say if ang direction sa atong current is consistent, let's say mo pass through siya ni R1, mo ubos po siya ni R2, then mo ngadto po siya ni R3. Now, if ang pag-analyze sa voltage in a certain loop, makasugat kay ka og kanang battery, and please, or any power source, please indicate yun sa iyahang sign siyang terminal. I-locate kung asa ang positive terminal and negative terminal. Now, if the direction of the current that you assume is look like this, maana siya ba? From negative to positive, meaning, sa may pasabutan na, we have an increase in voltage. Diba kung ato na siya ato siya tagsa-tagsaon. Okay, mo na inyo i-take note para di mo masayop. So, let's say, we have here a source of battery. This is the positive terminal and this is the negative terminal. Of course, kung ang imong gi-assume nga direction sa current is pangadto, okay, unsa may voltage niya. Of course, since the negative indicates that we have a zero potential or a negative potential, then miisa ka to sa positive, unsa may change in voltage niya na. Diba the change here is positive? Okay? Mo nang natay delta V dira, or the voltage nga generate niya is positive. However, if opposite ay mohang sign, let's say again another power source, okay, then ang yaha diri another pod, this is now the positive and the negative sign. If your direction is still from this direction towards the right, so diba unsa naitabo, there is a voltage drop. Notice mo, there is a left side positive siya, so kanang positive iyahang kanang voltage, then mi down siya sa negative, so there is a drop in voltage. Kung sa may nag-indicate we have a negative voltage, that's why we have negative delta V, or it depends upon the voltage of the battery. So here, since my direction, as you can see in this red arrow, my direction of the current is from negative to positive, therefore ang atong isuwat ang voltage is positive, because there is a voltage rise from negative to positive. Now, if baligali na ang sign sa imong power source, then you have a negative voltage. So, mana siya for power source. Next, sa may naa sa ato ang circuit, we have resistors or mga load or any devices. Now, in order to analyze any devices, let's say we have a resistor. Okay? All the time gid ka class, if makasugat gay kag resistor class, automatic, so may pasabot ana, what is the indication if atong current makasugat og resistor? Say pasabot ana, so may effect ana sa voltage. Diba? Mao galing ma-weak imong battery because ma-consume sa imong device. So therefore ang voltage niini is negative V. Okay, again makasugad gali ka sa imong pag-analyze nagay ko anaagal ay mga resistor or any devices, automatic that is voltage drop. So kana ni voltage drop nganong na may voltage drop nganong negative man, because may consume siya, mao gay ma-weak imong battery. Pag check nimo ana, kung i-check nimo using a multimeter, ang reading ana less than let's say your battery is rated at 12 volts. Pag check nimo gutra na maybe 11 or 10, kana siya, di na siya kapasiga because na-consume na yung voltage. So you need to recharge it again. So mo na kada device moagi gay ka, let's say that is the direction of your current, moagi ka at any resistor, ang ihadjud ka na is voltage drop, so negative siya. So here in our example, okay, example nato diri let's say ato focus is si kuan, the first loop, okay, loop A B E F. Okay, for A B E F we have kanang R1 resistor R1. So R1, let's say this is kuan, na siya may aging current. Okay, ato na ikuan nga current nga this is pare mo maglibog sa ni erase. Okay, for Kirchhoff's usal na naara na giset nga current. So let's say giset nga current diri is na current nga mo pass through diri nga I1, and then may pass through ni R2 is I2, and then here this is I3. Okay, of course ang mo agi ni R3 is I1, kay di ba si I1 ni continue man ari. So I1 ang may agi niya, the same thing with the battery and the same thing with R1. However for R2 si I2 kay na split baya. Si I3 mi join na pud, kay si I3 mo agi diri, unya mo join na pud siya diri nga node E, mag-meet sila ni I2, so therefore mo I1 na pud. So nga na pag-analyze ako. But anyways, don't worry kay in some problems gi-indicate man nila ang mga number of currents nga mo pass. However, there are some problems nga wala nigi pang indicate. So mao nang ako introduce ninyo ay kaduha nga method known as Maxwell. Kay Maxwell, even if wala gi suwat dira ang mga currents and its corresponding direction, you can still solve the electrical circuit. So balik ta, for loop A B E F we have two currents here na na-involved, duha ka current. So let's start with R1. So for R1 na current nga I1. So again, makasugat kay kag mga resistor or any load, negative gina siya. So just write negative R1 I1, because voltage is the product of this resistance times the current. Next, kung sa pinasa loop, we have R2, di ba? We have R2. So since nakasugat na pud ta og resistor, negative na pud kay voltage drop man na drop. So minus R2, this time I2 na. Next, what else? Kung sa pa may naa diri, kung sa pa may other device sa ato ang loop 1, loop ABEF. Kung sa pa man class, maklaro ninyo ang kan? Maklaro ninyo ang figure. Kung sa pa may naa, okay, kaning R3. So for R3 again, since resistor na pud siya, drop na pud iya voltage. So we have minus R3, and what is its current? Is it I2, I3 or I1? Ang sa man class. Okay, I1. So di ba I1 na siya. So that is I1. And then misugat siya ni battery. Again, don't forget, sa gikan ganiha, our direction of current is upward. Okay, upward. And then the sign of our kanang terminals is negative to positive. So if that is negative to positive, meaning from low to high, what is the change in voltage? That is positive. Okay, so in voltage in rise siya, or in voltage increase. So therefore we have plus E. that is the voltage of our source, and then equal to 0. So yan na pag-rewrite sa atong voltage law. So nasabtan ra? Walay pangutan na? Again na, marto siya, makasugat kay mo og resistor or any kanang device aside from kanang power source such as batteries, voltage drop kina siya automatic. And then for a battery source or any power source, you should indicate the sign of their terminal sides, and then also the direction of the current nga imong gi-assume. And then if the direction is from negative to positive, meaning from negative terminal to positive terminal, therefore that is voltage increase, so we have a positive sign. However, if the direction is from positive to negative, we have voltage drop, therefore negative siya. So mo na siya ang kanang Kirchhoff's nga law. We have for current law, more on node analysis ni siya, so nata sa mga node nag-analyze, and then for voltage law nata sa loop. And the second method is for Maxwell. Kanang ka Maxwell, kanang po gani kay makasolve ka bisag kuan unsa nga klase sa circuit. So for Maxwell, ang iyaha is it's okay if sa problem kay dili given ang mga kuan, dili given ang mga direction sa kuan, dili given ang direction sa mga currents. So kay Maxwell, kay Maxwell para nako siguro basig na ma-idea ni, for me Maxwell is kuan siya murag loop analysis, by loop analysis. So for Maxwell, let's say we have a given electrical circuit. I have here a power source, then we have a lot of loops, so daghan na kayo. For Kirchhoff, very kuan na kanin siya, medyo lisod na kaayo kay daghan na kag mga i-considered pod nya, daghan po kag nodes ari. So for Maxwell, mas simplified iyahan nya, mas masabtan nimo. So we have here R1, R2, R3, R4, R5, R6, R7, R8. Okay, for Maxwell class, and then this is our power source. Kay Maxwell, by loop ang iyang pag-analyze. So for a certain loop, okay, for a certain loop, mag-assume ka og current, direction sa current within that loop. So let's say here, ang obvious gid nga number of loops nga ato makita is 3, di ba? Tulo ka buok. But you can also have this loop kaning diri mag-start from R1, R4, R5, R3, then back to the power source. But try to lang. For Maxwell, try to indicate the direction of your current for for loops that can be seen easily. So ang loops diri nga makita dayon nato is kaning tulo ka buok, di ba? Kaning mga hole diri. So for the first loop, I'm gonna assume that this is the direction of my current. So I only have a single current here. Unlike Kirchhoff's law, daghan kay na siya mga current for every resistor here or for every branches. For Maxwell, usa ra ta sa usa ka loop. Let's say, okay, sa first loop, I only have a single direction of current here. So that is I1. Then please indicate the sign of the terminal sides of your power source. So we have I1. Of course, kailangan dili ingon pasabot nga ang may agi nga current ni R2 is only I1, since si R2 is also associated with the second loop. Now for second loop, I can also assume another current here. Let's say ang current nga nagtuyok ari is another current, and I'm going to indicate this one as I2. So here we can say that the current passing through R4 is only I2. Kaya wa na may influence niya lain. However, for R2, it's a different thing because R2 is influenced by the current I1 and the current I2. The same thing with R5, influence pod siya sa current nga ako ibutang diri for the third loop. Now in the third loop, assume na punta diri. So for third loop, I'm gonna assume that this is my direction of my current. So that I'm going to label this one as I3. So muna siya kang Maxwell. And then here, since we have 3 unknowns, right? Para mas madali ang pag-solve for Maxwell, so I make ko diri. Ato ikuan na this one we have 3 unknowns. We have I1, I2, and I3. Now, in order to solve for this unknown, di ba, remember sa inyong mathematics nga discussion, if you have 3 unknowns, in order to solve for these variables, you only need to have at least 3 equations. Okay, 3 equations. So, dapat maka-generate ka og 3 ka equations. And, unsaon man sir, unsaon na to pag-generate ni ani by using this Maxwell method. So, obviously, kay Maxwell is, since loop analysis siya, but anyways, kang Maxwell pod nga kaning analysis niya, yung method is also derived from Kirchhoff's law, katong the second law of voltages, wherein the summation of the voltage within a loop is equal to 0. So, since we have 3 loops, kanang koan, possibly in that loop we can, or for each loop we can generate a single equation. So since namtay tulo ka loop, automatic tulo pod ka equation dayon ang ato ang ma-generate. So nakuan ra na nakasunod pa mo class? Nakasunod pa? Okay, please tell me lang if naikuan, if paspas ba or sagarat ba or nag-freeze ba ang kuan. So for loop 1, okay, for loop 1 kaning color blue, so ang kang Maxwell class, again we only have a single current here, I1. So let's start with R1, kay naman si R1 sa loop 1. So for R1 to ibutang diri, that is again voltage drop ni siya. Again voltage drop ni siya kung moagi og any resistor or any other devices aside from the kuan battery. So we have negative R1 kay voltage drop, then I1. Then for R2, again voltage drop kung moagi si I1 ha, so that is negative R2 I1. However, we have another current here. Okay, ayo jud kalimting nga si R2 duha nag-influence niya, that is I2. And since I2 is opposite to the direction of kanang kuan, to the direction of kanang I1, so unsa may kuan ana, unsa may pasabot ana, we have a positive, okay, a positive sign here, that is voltage increase. Okay, unlike I1, di ba ang ato ang kanang ang atong nakaugalian kay if pass ta og current ni R2, voltage drop, that's why we have negative. However, if ang direction ni I2 unta, if pareha silang direction ni I1, negative unta ni siya. However, opposite man siya, di ba? If we have an opposite direction, meaning opposite pod ang sign. So, if the sign of our I1 here is negative na, so I2 is automatic positive. So we have plus R2 I2. Tungod kay sukwahi sila. Sukwahi sila sa kuan, lahi-lahi sila og kanang sign, or lahi-lahi sila og direction. So we have plus R2 I2. And then next, wa na may lain nga nag-interact. So therefore, final na to nga isuwat is kaning E. Since the direction of I1 follows that it passes from negative to the positive terminal, so we have voltage rise. That's why we're going to put here plus E is equal to 0. So this would be our equation 1. So yun siya class. And then duha na lang ka equation na tong kailangan. So ngadto na ta sa loop number 2. So for loop 2, so here naatay upat ka resistor. So for loop 2, let's start with R4. So again, ang direction nato diri sa current si I2. So pag-pass ni I2 ni R4, automatic voltage drop normally. That is R4 I2. Then ni-pass na po siya ni R5. So si R5, in terms of I2, voltage drop na pod I2. However, for R5, di lang kay si I2, influence pod si I3, but opposite. So therefore, this is positive na, kay opposite man ang direction ni I3 kay I2. So that is plus R5, then I3. Next, si I2, may pass na pod. Sa second loop na po R3. So we have voltage drop again, minus R3, I2. Then, balik na pod ka ni R2. So, voltage drop na pod with respect to I2. So, that is minus R2, I2. However, for R2, may influence pod si I1, but in opposite direction. So, therefore, take it as a positive. So, plus R2, I1. And then, what naman yung line equal to 0. So, this would be our equation 2. Now, we can also combine this one para ma-separate nato in terms of I2, I3, and I1. And for the last equation, we have for loop number 3. For loop number 3. So, here, we have 4 resistors involved. Let's start with R7. Ang nag-interact ni R7 is only I3. And again, normally, voltage drop na siya. So, we have negative R7, I3. Then, ni R8 na pod, minus R8, I3, kay voltage drop man. Si I3, misugat ni R6, that is minus R6, I3. And then, for R5, voltage drop na pod, minus R5, I3. However, not only I3 may interact ni R5, diba, resistor number 5, but also I2, ang second current, but with opposite direction. So, we're going to take that one as positive. That is plus R5, I2 is equal to 0. So, this would be our equation 3. So, by having this 3 equation class, now, you can have your calculator, or mas better kung nyo i-show, but you can use method of substitution, elimination, or kanang Gaussian to solve for these 3 unknowns. So, ingan nira ang technique class paggamit kay Maxwell method. So, by loop ang iyang pag-analyze. Then, mostly ang goal niya ani kay maka-generate og mga equations nga naa dira ang atong mga unknowns. So, walay pangutana ani. Okay, so mara ito'y tigam ninyo. Katong mag-agigali ang current sa resistor ini device, then voltage drop negative. Kung naapagay mo interact niya nga current, but in opposite direction, I'll just take it as a positive. But the same gali ang direction, I'll take it as negative gihapon. Voltage drop gihapon siya. Okay, so let's have our first problem. So here, find the currents daw in the circuit shown in figure 18.15 by using Kirchhoff's rule. So, Kirchhoff's rule sa ta. So, maklaro ninyo ang figure. Maklaro ninyo, class? Figure. Okay, so, asa man ka, since we're using Kirchhoff's rules, so diba we have 2 laws there. The first one is for current and the second is for voltage. So, asa man ka nga node ang atong pilion in order to analyze using the current law. Asa may pinaka-efficient nga node ang atong mapili para makakuha din ta or makaderive din tag equation that will relate these 3 currents. Is it node B? Kani mga nodes mo na siya indicate, kani mga dot. Node B, node A, node D, node C. Asa man nakahaan eh. So, namatay power source, so yung gidikit positive, negative, and then kaning blue nga loop, nag-indicate na siya sa direction sa atong current. So, again, for analysis sa Kirchhoff's, dapat imo pod indicate ang direction. So, here, obvious naman kay di ba si I1 kay padong ari, misod siya ni 4 ohm nga resistor, mi-split. So, manang sa node C, diri makita nato nga may enter si I1 at node C, mi-split mo nang natay I2 padung ni 5 ohm resistor, naputay I3 padung ni 9 ohm resistor. Then this I2 and I3 will meet again on node D. Unya mugawa siya, mubalik na pud ni I1. Mosod sa battery, then mo-repeat itself na pud. Yan na ra. So here, pinaka-efficient nga node nga atong pilion is ang node C. Okay? So, on dire node C. Okay, in node C, we can generate an equation that will relate these three currents. So at node C, di ba? Ato nang kanon dira nga node. If we're going to extract that node, so natay resistor mingadto. So this is node C. So ang may pass or ang may enter at node C is we have I2. Diba? I1. I1 kani siya. Misod bi ana pa daw ngara. That is I1, then mi-split siya. Ay may gawas is I2, and then diri pud sa ubos is I3. So meaning in this diagram we can say that we have I1 is equal to I2 plus I3. So we have three unknowns here. At least we need to have kanang kuan three pud ka equation. So ato na i-label nga this is our equation 1. So duha na lang ka equations atong kailangan. So we're going to use the second one because if we're going to use another node na pud class, magbalik-balik ra ta. Let's say kung gusto ka may itaglaing equation, mag node D ka. Sa node D is just equal to I2 plus I3 equal to I1. So balik-balik ra ta. Na naman ta ani which is from node C. So para di ka magbalik-balik, magtuyok-tuyok imong solution. So let's proceed to the second law. That is the law of voltage. Katong voltage law. And diba ang voltage law is by loop. Okay? So let's start in analyzing loop. Kanang sa ubos, that is loop BCDA. Loop BCDA. And if we're going to draw this, so we have here power source. Ngato siya, then natay 4 ohm resistor, may baba, na another resistor, may taas, then may balik. So here, this is positive, negative sign. This is our 4 ohm resistor. This is our 9 ohm resistor. And then, wala. So here, to indicate that this is the assumed direction of our current. And here, for resistor number 4, natay may agi nga current ari class. That is current, unsa man? Unsa may current nga may agi sa 4 ohm resistor? Unsa may agi class? Unsa may agi diri sa kuan? Sa 4 ohm resistor nga current, is it I1, I2 or I3? Unsa man? I1. Okay, so I1. So I1 ang may kuan ari sa 4 ohm resistor. So imibutang, okay, this is I1. And then for how about kuan? 9 ohm resistor. So may agi diri. May agi diri kay I3 na, di ba? Based on our diagram here, I3 na may agi diri. So we have here I3. And then may balik na pod siya. With this node, may split man gud og may converge na pod. So here we have two currents involved, I1 and I3. So let's start analyzing this loop. So to analyze this loop, consider all the devices or resistors or batteries nga connected in nga loop. So we have 2 resistors and 1 battery. So let's start with the resistor. again, for every resistor, we have a voltage drop. Kung mupass niya ang current, voltage drop yun na siya. So, ato ikuan. Ato isulat. So, for I1, we have negative 4 I1. So, that is the product of the resistance nga value multiplied by the current. Negative siya. So, next, for the 9 ohm, negative gyapon na siya. Minus 9 I3. Again, anong negative? Tungod kay for every devices or resistor nga magian sa current, voltage drop yun na siya. Kaya consume man na sila voltahe. Next, since nakasugat man ta og battery, and kung i-consider nato ang direction sa current nato, di ba pangadto siya? So meaning, that is from negative to positive. Pag sugat niya sa battery, we have voltage increase. So therefore, the sign of our voltage here is positive. Kaya kita iyahang terminal sides from negative to positive man. So that's why we have plus 6 is equal to 0. So gi-0 na ako kay wala may lain nga mga devices or any batteries nga present. So that would be for our first loop. Now, this is equation 2 ni siya. So unsa man lay kuwang nato? Usa na lang ka equation. So lucky ta kay napamay usa ka kuan, usa ka loop. So that is loop na kanang CD. Okay? Ato i-draw si loop CD. Nagana na siya. Ana, then napo sa diri. Then may ana. So here we have 5 ohm nga resistor. Sa ubos we have 9 ohm resistor. So here ang pass through ni 5 ohm resistor is current I2. So may pass through si I2. Then for the 9 ohm resistor, si current I3. So again si I3 kay padong adto. Kaya I3 padong ato. Take note, unya, don't forget yet to indicate the assumed direction of the current for the Kirchhoff's law. Again, since diri thankful ta kay sa ato ang problem, indicate ang direction sa direction sa current kanaging arrow nga blue. Kung napansin kani siya, kaning blue nga arrow nakita kani siya. So kani blue nga arrow mo na siya assumed direction. Again, in analyzing Kirchhoff's law, both Maxwell and Kirchhoff ay kalimti ang yung assume may direction sa current. So ato na ibutang diri, assume na nga mo na ato follow nga direction sa current. Anything else nga mo labag ana nga direction is opposite iha sign. Para gid diri sa first atong loop mo na atong assume direction. Kana anything else nga mo labag ani mo change yang sign. So manang here wa may milabag kay si I1 o si I3 may follow man ano nga direction, so therefore both of them receives a voltage drop, manang negative na sila. So here for this loop si I2 may follow siya sa atong assumed direction. So buotan na siya kay sunod. So since si I2 kay may pass sa sa resistor nga 5 ohms, so therefore voltage drop we have negative 5 times I2. However, sa atong assumed direction, supposedly, I3 should be towards the left. However, si I3 na daan class, based sa ato ang figure, is towards the right na siya. So, misukwahi siya sa direction nga ato ang gi-assume. So, what does this mean? Based on our assumed direction, dapat siya naka-voltage drop. But since naka-opposite man siya, we take it as a positive, diba? Positive siya kay normally kung mo follow pa lang siya sa aning assumed direction, voltage drop siya negative. However, opposite man ang I3, opposite man siya sa atong assumed direction. Okay, atong assumed direction is pangadto man ta dapat siya kay pangadto man sa right. So therefore we have plus here, plus 9 I3 is equal to 0. So this would be our equation 3. Now, usahon nato ang tulo ka equation. So, let's start with equation 1. So, ato sila usahon. ato i-rearrange nga mag-una si I1 followed by I2, then next I3, and then equal to the constant. So for equation 1 we have I1 minus I2 minus I3 is equal to 0. So ako na siyang ipan-transpose dira ana. Next for equation 2 we have negative 4I1 minus plus dahil 0 I2, so we don't have I2 here ha, na wala may I2, only I3, so that is minus 9 I3. We're going to transpose this 6 on the other side, so we now have negative 6 here. Okay, that is for our equation 2. Next for equation 3 we have negative, we don't have I1, so put here 0 I1, I2 is negative 5 I2, then the last one is plus 9 I3 is equal to 0. So solving for these three unknowns I1, I2, and I3, now you can have your kanang calculator, or you can use method of substitution or method of elimination. So para mapaspas ta, gamit lang ko din sa akong calculator. So input lang ilang mga coefficients, negative 1, then negative 1, 0, then negative 4, 0, negative 9, then negative 6, we have 0, negative 5, 9, and 0. So the answer here, we have I1, so I1 is equal to 84 over 101 amperes. For I2, nakakuha ko og 54 over 101, so 54 over 101 amperes. Then for I3, we have 30 over 101 amperes. So mana siya ato ang answer for our three currents I1, I2, and I3. So naipangata na. Naipangata na class. Okay, nakasabot ra. How about the others? Kasabot ra? Okay, nakasabot ra? Okay. So, marami pang utana din. Let's proceed to the second problem. So again, another na pod nga electrical circuit. So we're going to solve for I1, I2, and I3 in this figure. So again, we can use Kirchhoff's law or Maxwell. So ako ipakita ninyo kung magkapareho ba silang answer if we're going to use Kirchhoff's or Maxwell. So here, we're going to use Kirchhoff's muna. So by Kirchhoff's law. Or by Kirchhoff's rule. So let's start with the current. So the current law. And then here, we're going to choose node C. Kaya obviously, based sa ang figure, si node C na drag indicate ang mga currents, that is I1, I2, milabas siya I3. So node C. Okay, at node C, unsa may current nga mi enter, that is I1 may enter sa node C and also I2. So you have I1 plus I2 is equal to ang hinggawas, that is I3. So this would be our equation 1. So since we have 3 unknowns, automatic at least 3 pod ka mga equations ang ato ang kailangan nga kuhaon. So here we now have the first equation. So we only have 2 remaining equations nga atong pangitaon. So since obviously ato makita we have 2 loops here, the upper loop and the the lower loop. So napud tayo duha ka equations ni ani by using the second law, the voltage. So let's proceed. So voltage law. So for voltage law, we're going to consider first the upper loop. So ato i-draw ang atong upper loop. Okay, ato i-draw ang atong upper loop. So we have here a power source, duha dito ka power source sa may interact diri ah. So draw na tong upper loop, na resistor. Then here na po other resistor, and then na po tay source of battery here or source of power. So here, please indicate gyud ang mga signs sa terminal side sa ato ang mga kanang kuan battery. Indicate na to. And then ato pod ipang indicate og tarong ang direction sa current since Kirchhoff's man ni. So ato indicate ang mga direction sa current sa ato ang tagsa ka mga resistor. So ang miagi ni 6 ohm resistor is unsa man nga current based on our drawing class. Unsa man nga current ang miagi diri ah. Okay, I1. So and the direction is towards the right. So this is I1. The next, we have another resistor here, the 4 ohm resistor. So si 4 ohm, again ha, si I1 ug si I2 misugat at node C. Mo nang na-produce si I3. Si I3 midagan pa dong ni 2 ohm resistor, then patong ni B mi-split na pod siya. That's why mi-split siya balik pa dong ni I1 ug pa dong sa babaw ni I2. So therefore, ang miagi dayon ni 4 ohm resistor is I2. So indicate there I2. And then of course, ang miagi pod sa ato ang 14 volt nga battery is the current I2. So butan nimo I2. And then for the 10 volt nga battery, miagi niya AC I1 in this direction. That is I1. Ay na kalimti. Kada device mas safe gyud nga inyo indicate ang mga currents ilang direction. And then ikaw na bahala pag-assume og current direction. So for this loop, medyo ako ni sundo ning I2. Okay, direction sa I2. It's up to you. Pwede kag kani imong i-draw kani or ang pabali. Baliktad. It's up to you. Kay kuan anyways, makorek raman ka with the help of your kanang kuan katong imong final answer. So here, ako i-assume nga dili na lang ato ang direction. So meaning sa may pasabot niya ni, if this is my direction of my current, so whatever current nga mi sunod ni nga direction, kung makasugat siya mga devices such as resistor and kanang other devices pod, kuan siya voltage drop. Okay, however kung ang current na ay current ani nga hinsukwahi, so meaning opposite siya, sa may indication na naatay voltage increase. So opposite iya direction. Instead of having negative, ma-positive siya. Okay, that only applies for saman apply na siya sa mga resistor na other devices. However for kanang kuan batteries, so mato ang gikan nyo ganiha, follow the direction of the kuan kaning ato ang sign diri kaning blue, i-follow lang ni siya, mo ninyo i-follow. Okay, para di ta maglibog. So here ato na ni reasoning direction ni kuan kaning 10 volts kani. So para di maglibog, kay di ba ingon naman ko nga kaning atong mga direction is only for kuan na dito, only for the resistors and other devices. So for the battery, follow ta ani nga direction kani akong giset nga assume ko ani nga direction kaning blue. So mo na to ang gi-assume nga direction. So here, once na set na nimo imong gi-assume nga direction and then also the direction of your resistors, so again ha, okay ra kayo dili i-indicate di ay ang direction sa current nga mipas sa imong battery, because ang battery kay ato lang siya i-depend upon the direction nga imong gi-assume. So maning blue akong ibutang. So here, let's start na sa pag-analyze. So good ta ni battery. Si battery, ang assume na to nga direction kaning blue is from positive to negative band. So unsa may pasabot ana, we have a voltage drop. Okay, we have a negative sign. Remember sa kato akong ikuan ganiha. So, negative sign ang ato dira. So, we have negative 14. Okay, from positive man, kita ang direction sa akong arrow, kaning blue nga arrow. So, from positive to negative, voltage drop. Next, kaning blue, miagi siya aning 6 ohm resistor, kaning nasa ubos. However, ihang current nga si I1 is opposite man siya. So, unsa man siya, voltage drop or voltage increase. Na kay opposite man ang direction ni blue o kaning gi-assume nga current direction, kaning current 1. So, unsa man diri, voltage drop ba ni siya or voltage increase? Unsa man diri class? Increase. Di ba positive sign siya diri kay opposite ba iyaha direction sa I1 with respect to the assumed direction nato kaning blue. So therefore we have plus 6 I1. Okay, then miagi na pud ta og another battery. Here ang battery nato with our assumed direction kaning blue is from positive to negative. Okay? From positive to negative. So unsa may pasabot niya na? We have minus 10. Okay? Minus 10 volts. Then next, si 4 ohm nga resistor. Okay, si 4 ohm nga resistor, ang iyahang direction diri is iyang direction diri is along this assumed direction nato nga blue. So diba, pa-upward siya. So therefore we have a voltage drop here. Pasabot ana, we have negative sign. That is minus 4 then multiplied by I2. Then what na may lain, so equal to 0. Now we're going to rearrange this in terms of I1, I2, and I3. So let's start with 6I1 minus 4I2 then plus 0I3. What mata I3 equals kani siyang 14 and 10 ato na siya i-transpose, so we have positive, that is plus 24. This should be our equation 2. So 24 na ni kay ma-transpose mo on the other side. So man na siya, and then let's proceed to the lower loop. So at the lower loop nata to drawing ang lower, so we have the 10 volt nga battery, then resistor here, then diri na pod another resistor, then balik. Then please don't forget to indicate the sign of the terminal sides of the battery. Then this is 6 ohm nga resistor, this is 6 ohm nga resistor, then this is 10 volts, then sa lower 12 ohm nga resistor. So here, indicate na po nato ang mga direction sa current for each resistor. So for 6 ohm, padong siya ngadto. This is I1. Then next, for the 2 ohm resistor, ang miagi niya is si I3. So put here, the direction is I3 here. Then, what else? So ano may lain? So ato na na-define. Next is, mag-assume ta og direction sa atong current sa loop. So the same thing atong ibuhat kaning blue. So I'll assume nga mo ni ang direction sa current paana. Okay, paana siya. So after this, we're now ready to write the equation. So here, let's start with the battery. So the battery, ang assume nato nga direction kaning blue is from the negative to positive. So say pasabot ana from negative to positive. So we have a voltage increase. Okay? So right there 10. Then since ang direction nato ni I1 at the 6 ohm resistor is along the direction of our assumed nga direction sa current kaning blue, same man sila. Therefore, we have a voltage drop there. So minus 6 I1. Then ang direction pod ni I3 matches the direction of our assumed current kaning blue. So therefore, another voltage drop. So right, minus 2 times I3, wala may lain, equals 0. Rearranging, So mag-una ta ni negative 6i1 followed by 0i2, may i2. Then next minus 2i3. Now i-transpose si 10 on the other side. So we have negative 10. This would serve as our third equation, equation 3. And here, diri makaderive ta sa ato kuan. Ato na ma-solve kay na naman tayo tulo ka equations, then we also have 3 unknowns. So ato ilista. So for the first equation, rearranging this, so we have i1 plus i2. So si i3 ato i-transpose ni siya. So we have minus i3 is equal to 0. The second equation naka-arrange. So we have 6i1 minus 4i2 plus walay i3. So 0 na lang i3 is equals to 24. For the third equation, we have negative 6i1 plus 0i2 then minus 2i3 is equal to negative 10. So we have 3 equations here and 3 unknowns. So for the meantime, magamit lang ko sa calculator para madali ta. So i-input na mo sa calculator, pili ka itong equation nga solver. For 3 unknowns, i-plug in na nimo ang mga ilahang mga coefficients. So 1, 1, negative 3, negative 1 din siya, negative 1, then 0, then 6, we have negative 4, 0, then 24, then negative 6, then 0, then negative 2, then negative 10. So ang ato ang I1, our I1 is equal to 2 amperes. Our I2 is equal to negative 3 amperes. Our I3 is equal to negative 1 amperes. So class, unsa may pasabot aning I2 nga negative 3 amperes? Unsa may indication ana? Unsa may pasabot ana class? Kanang negative. Class, unsa may indication? We have negative I2 and I3. Okay, pabaliktad. Diba? Pabaliktad ang direction. So, I2 di is pababaw ni siya. Okay? So, kung ato na siya correctionan, kumbaga. So, I2 is pababaw din ni siya. Si I3 pod kay asaman, pababaw pod. Okay, so yan na siya class. And ato na isuwat diri kay to prove nga magmatch ba kaha ang method ni Maxwell og ni Kirchhoff. Of course, magmatch gina sila. So I1 is 2, I2 here is negative 3 amps, and then si I3 is equals to negative 1 amperes. Okay. So, we're going to use the Maxwell nga method, ang ikaduha nga method. So, ato na siya erase. Kang Kirchhoff's man eh. So, anyways, wala na may ikuan ni, wala na question. Wala na question class sa sa solution. Naklaro ra? Para okay ra, nasabtan ra? Okay, sige. So, ato na erase. So, we're going to use the Maxwell nga method. So, ito ikuan. Maxwell method. So for Maxwell nga method, kanang kuan ra ta diri, di ba kay by loop man atong analysis here. So for Maxwell ato ning pang erase ning mga kuan, mga samok diri kana. So for Maxwell, duha ra ka current ang ato ang ma-solve ari, di ba? But of course ma-solve ya po na natong kanang tulo ka currents nga gi-indicate dira. But this method gyud duha ra makuan ani ma-solve. Okay, duha ra. Okay, duha ra man ka loop, di ba? Kay loop analysis man siya. So duha ra ka kuan. Duha ra ka current. So for the upper loop, I'll assume nga mo na akong direction sa akong current. Okay. Then for the second loop, I'll assume nga mao pud siya. And para di ta maglibog, since kani nga method ka Maxwell og kang Kirchhoff kay lahi gini siya, so ako ni i-redraw para di maglibog kay tangtangon na natong mga gibutang dira nga mga currents, direction sa currents. So here I have a battery. So again kay Maxwell, importante gid gihapon nga indicate ang mga sign sa terminals, then obos, then naa diri resistor, then another battery source, then another resistor, and that's it. So this is negative and positive terminal, and here label the values. So this is a 6 ohm resistor, 4 ohm resistor, this is 14 volt battery, this is 10 volt battery. Ang nakanindot mangod kay Maxwell kay kuan man ni, this is the upper loop. Ang nakanindot kay Maxwell kay di na ka magbutang-butang asa ka diri ang direction sa current ni nga mopas ni 4 kay by loop man siya. So sa usa ka loop usar ka current akong gi-assume dira. Okay, so I have here assume ta nga direction is mo na siya, mo na, and I'm going to label this one as I1. So there is a to figure, this is I1, then this is I2. So mana kay Maxwell, mara na siya, I1 na siya. And just follow its direction. So kay Maxwell, mo na to siya nga kanang kuan nga kung makasugat siya og resistor, voltage drop dayon. And then for battery, mag-agad kung if that is from positive to negative, that is voltage drop. If from negative to positive, voltage rise. So here, our assumed direction is mo na siya. So let's start with the 14 volt battery. So si I1 is from positive to negative. Diba si I1 may agi sa battery from positive to negative. So we have voltage drop. So we're going to write negative 14. Then next, si I1 may agi ni 6 ohm resistor. So kada agi niya ni 6 ohm resistor, voltage drop dayon. Mao na ka Maxwell. Wa naman ta diri pareha sa Kirchhoffs nga natay diri I1 nga gikuan gibutang. So kay Maxwell gineglect na to. So labay siya, automatic voltage drop minus 6 I1. Hinglabay na po siya ni 10 volt battery. Paglabay niya iyang direction kay from positive to negative. Pangadto man siya pangadto. Back ang tuyok niya, ang turning niya. So we have kanang kuan kanang voltage drop kay from positive to negative man. May negative to positive kay voltage increase. So that is minus 10. Then may agi na pod siya ni kuan. May agi na pod siya ni 4 ohm resistor. So again, makaagi kay siya voltage drop. So minus 4 I1, then ano may line equal to 0. So rearranging this equation 1. Sorry. Sa Maxwell, we forgot to put the second loop kay nabada interaction because kani si 6 ohm nga resistor napay nag-interact ni ini. So ato sana siya ipang remove ni ilang makuan para maklaro na to. So kani ito na i-extend. I forgot to put. Okay. So again, mas may butang kay ang interaction ni 6 ohm dili lang kay si I1 kay nabay I2 pod. So ato ibutang diri. This is 2 ohm resistor, then this is 10 volt battery, then this is 6 ohm resistor. So here indicate ang direction ni I2 sa ikaduha nga loop. So this is I2. Okay, ana. So balik ta for upper loop. So for upper loop, so again kung maggamit mo ni Maxwell method, iswat lang tanan. Iswat ang tanang loop kay dira nato makita ang interaction sa bawat mga resistors. So for upper loop balik ta, sugat siya ni 14 volts voltage drop kay positive to negative, so negative 14. Pag sugat niya ni 6 ohm resistor with respect to I1, that is voltage drop, so minus 6 I1. However, ni-interact pod niya si I2 kay labay man si I2 ni 6 ohm resistor, so therefore opposite pod si I2 kay I1, so we have positive, so that is plus 6 I2. Then milabay ang atong current ni 10 volts, so ang direction is from positive to negative, so we have voltage drop, so we have minus 10. So class ay kakuan nga, oy sir, labay mo pod si I2 sa 10 sa kanang battery. Actually for a battery, assume na tanin ni I1 since ang battery kay naka volts naman siya, di man siya function as voltage times current times resistance. Naka volts naman siya, so that's why we have this. Sundan lang kung unsay naa nga direction sa loop. The next, milabay siya ni 4 ohms, so that is minus 4 times I1. That is equal to 0. Rearranging, maguna si I1, so we have negative 10 I1. I2 is plus 6 I2 is equal to, matranspose ng 14 and 10, so we have 24 positive. So this would be our equation 1. That is for the upper loop. For the lower loop, natuta ni lower loop. At the lower loop, mag-unata ni 6 ohm resistor. So 6 ohm resistor, with this direction, kaning I2, voltage drop na siya. So we have negative 6 I2. However, may-interact pod si I1 at opposite direction. So we have voltage increase, kaya opposite man siya. So that is plus 6 I1. Next, milabay si I2 ni 2 ohm resistor sa kaning ubos. So we have voltage drop minus 2 I2. Then, of course, atong current milabay sa kaning 10 volts battery from negative terminal to positive. So, unsa may pasabot ana, we have voltage increase. Okay, from negative to positive man. So we have plus 10 is equal to 0. So rearranging, we have 6I1 minus 8I2 is equal to negative 10. So this is our equation 2. Now, solving for kuan, so ato ilista diri, we have two equations. Negative 10I1 plus 6I2 is equals to 24. And then here we have 6I1 minus 8I2 is equals to negative 10. Now, you can use kuan method of substitution or elimination. So para madali ta, nagamit lang ko sa equation solver. So here we have negative 10, then 6, then 24, then 6, then negative 8, then negative 10. So our I1 DI is equal to negative 3 amps. Our I2 is equal to negative 1 amp. Okay, so ang atong answer dito is negative 3 and negative 1. So medyo closer na. But how about this I1 nga 2 amps? So in order to solve for this I1, kaya diba ang I1 is the current nga ni-influence ni 6 ohm resistor. So unsa may milabay ni 6 ohm resistor based on Maxwell? Diba? Ito ikuan diri ha, so what? At 6 ohm nga resistor, ang current dira is the difference of I1 and I2. So that is I1 minus I2. Diba? Naparalan ninyo? Nasunod ninyo, class? Okay. So, mao nang kay Maxwell, diri gipangita kay I1 automatic kay Maxwell makaibaw bita nga ang I1 mao na ang current nga may interact ni 6 ohm. So, based sa result ni Maxwell, ang may interact ni 6 ohm resistor kay the difference between I1 and I2. So, I1 is negative 3 minus I2 is negative 1. The answer is negative 2 amperes. Kung sa may pasabot ana, therefore, kaning I1 nga atong gi-assume, di ba ang I1 kay direction kay padong sa left? So, negative siya, padong din siya sa right. Mao gini ang true kaning naa sa figure gid. So, it's okay if you have negative answer. Anyways, the direction maora gid na ang mag-change. So, nakuha na nato. Same na sila aning result. Now, of course, ang I2 is the current that interacts our resistor 4. So, unsa may interacting resistor 4 here based on Maxwell, that is I1. So, that's why we have I1 of negative 3. Okay? Here, si I3 daw is from Kirchhoff, that is negative 1 ampere. And that I3 interacts our resistor 2. 2 ohm resistor sa lower part. And based on Maxwell, ang may interact ni 2 ohm resistor is the current I2. And its result proves that because its result is negative 1 ampere, which is the same with our Kirchhoff's, that is negative 1. Okay? So, naklaro na? Walay pangutana ni? Wala na? So, sa inyo, which do you prefer, class? Class, asa mo prefer sa Kirchhoff or kay Maxwell? Sa inyo, based sa inyong kuan. Sa pag-solve po ninyo kay diba nahuman naman mo. So, asa mo prefer? Ha? Maxwell? Okay, Maxwell kay kuan naman. Kani kay Maxwell kay kuan naman siya. Dali ra kay by loop man siya, so ina to i-neglect tong mga magtagsa-tagsa pa kag kuan. And again, mo gini essence nga di mo maglibog. Ang una ninyo indicate in direction gid sa inyo hang current gid. And din ka Maxwell class, ma-apply ni bisag unsa pa nakalibog na imong circuit basta as long as imo siya ni arrange nga nay loop. So imo din circulan mo ang kaning loop, mo ni akong current direction. So moagi kay resistor, any resistor bang voltage drop. Nya kay Maxwell imong pong bantayan nga C28 nga if kana gay nga resistor kay naapoy lahi nga current nga nag-interact ana. So ang kadto nga current nga lahi nga mi-interact niya, opposite na to og sign. So mo nang sa ato ang mga calculations na positive to siya. Kay so kuha man to sa imong gi-assume. Okay, so if what na may question, then let's proceed to problem number 3. So here, consider the circuit shown in figure 18.11. Find the potential difference between points A and B and the current in the 20 ohm nga resistor. So here, ako introduce ninyo si Maxwell. So let's start with the Maxwell nga method kay based sa inyong giingon, so you find Maxwell nga kanang mas dali siya. Okay, Maxwell method. So based on our electrical circuit diagram, pila ka loops ang inyo makita? Makita tayo pila ka buok. Class, pila ka loops ang inyo makita? Okay, tulo no. Tulo din ang makita obviously. So, ato na ikuan ron. So, ako sa gidrawing ang kuan ang diagram. Okay, so tulo man na siya. Then don't forget to indicate the the sign of the terminal side. So this is positive, this is negative. So label also the given ng mga values. This is a 25 volt na battery. This is 10 ohms. This is 10 ohms, and then this one is 5 ohms, and then this one is 5 ohms. This one is 20 ohms. Okay, after that, since naka Maxwell Method, so since we have 3 loops here, I'll assume for every loop mag-assume tag direction sa current. Ato i-label nga kana nga loop usa ang current dira nga nag-govern. So for the left side nga loop, mo na ato ang direction i-assume. And we are going to label this one as I1. In the second loop, mao po ni siya. This is I2. The third loop, ana po siya. And this one is I3. Okay. So good ta ni loop 1. So at loop 1. So again, for every loop, natay I1 starts with the 10 ohm resistor. So with respect to I1, normally ato gibalik-balik voltage drop. So we have negative 10 I1. However, dili lang si I1 ang interact ni 10 ohm resistor. Naputay I2 at opposite direction. So if that is opposite siya sa kaning negative nga 10 I1. So that would be positive 10 I2. Okay? Then what else ang naa sa loop 1? Natay another 10 ohm resistor here. So pag agi ni I1, voltage drop na po minus 10 I1. Wala na may line interact niya, so remain as it is. Next, nanaputay battery. Based sa atong assumed direction, the battery kaning current travels from the negative terminal to the positive. Kung sa may pasabot ana, if that is the case, kung negative siya mo travel padung positive, kung sama siya class, is it voltage rise or voltage drop? Kung sama to siya class? Voltage rise or voltage drop? Unsa man? Voltage rise, di ba? Para di po maglibog, ikuan gid mo ka kung negative na siya, i-treat nimo siya nga gamay jud kay mga numbers. Mga negative numbers ba niya, positive dako ang number. So meaning, kung mo agi ka from smaller number of voltages to higher, voltage rise na siya. So that's why we're going to write here positive. So plus 25, then ano may line equals 0. So this would be our equation 1. Okay? So since kuan man we have 3 unknowns nga current, so we need at least 3 equations. So let's proceed to loop number 2. So here at the second loop, so at loop 2, okay, at loop 2 ato ikuan diri. So here duha ra ka resistor ang interact diri, the 5 ohm and the 10 ohm nga resistors. So let's start with the 5 ohm. So since I2 man ta, I2 ang atong gi-assume nga direction ha. So voltage drop negative 5 I2. However, for this 5 ohm resistor, may interact pod si I3 at opposite direction. So that is positive 5 I3. Next, si I2 may pass through ni 10 ohm resistor sa left side and voltage drop na. So minus 10 I2. Next, not only I2 ang may interact ni 10 ohm but also I1 but in opposite. So that would be plus 10 I1. Wala may lain equal to 0. Rearranging this, so we have unya na lang sa pagkuha na to. So ato na isuwat para madali ta. So mana siya ang equation nga generate at loop 2. Next, punta ta ni loop 3. So at loop 3, here I3 na atong gisunod nga direction. So we have 3 resistors here, the 5 ohm and the 20 ohm on the left and 5 ohm on the right. Let's start with the 5 ohm resistor on the left. So si I3 may agi dira voltage drop, so negative 5 I3. Miagi na po siya ni 20 ohm, voltage drop na po, minus 20 I3. Miagi siya ni 5 ohm on the left side, so minus 5 I3. Then, ni 5 ohm sa left side, mi-interact po si I2 at opposite direction. So that is 5 plus 5 I2 equal to 0. So this would be our equation 3. So from these three equations, we're going to rearrange this one and solving for the unknown parameters. So ato ikuan, the first equation ato i-arrange ni siya. So nag-start ta ni I1. So negative 10 I1 and negative 10 I1. So we have negative 20. Negative 20 I1. For I2, we have plus 10 I2. And then we have positive 25 here. Ato i-transpose on the other side. We have equals negative 25. Ato ba na iswat si I3? But 0 lang siya. Anyways, mas better is ato iswat para makita ito ilang mga coefficients. So, plus 0 I3 equals negative and 25. Next, second equation. We have I1 of 10. So, that is 10 I1. Next, si I2, ato ni combining negative 10 and negative 5, we have negative 15. Negative 15 I2. Next, for I3, we have 5. So, we have plus 5 I3 is equal to 0. The third equation, we don't have I1. So, 0 si I1. We have I2 of 5. Can you see there? Plus 5 I2. And the next, combine the coefficients for I3. We have negative 5, negative 20, and negative 5. So, that would result to negative 30. I3 is equal to 0. So, we have 3 equations and 3 unknowns. So, ato na po siya i-solve. So, nako din sa akong solver. So, input atong coefficients, negative 20, 10, 0, negative 25. We have 10, negative 15, 5, 0, 0, 5, negative 30, and 0. So we have for our I1 is equal to 85 over 44 amperes. Our I2 is equal to 15 over 11 amperes. Our I3 is equal to 5 over 22 amperes. Here class, pata sa ato ang required. Atong required una is the potential difference daw between points A and B. Kasi pasabot ani niya. So, in our diagram, ang points A and B is located here. Ano siya? Diri between this 10 ohm resistor B and A. Okay, unsa ray voltage nga dira? So kato i-analyze, the voltage there is just, okay, ato i-kuan dira. Ito suwat. For A, that is the voltage at B to A, or that is just equal to the voltage at the 10 ohm resistor, di ba? Pareha na siya. Voltage dira sa 10 ohm resistor, which is also equal to the voltage at the 5 ohm and the voltage of these two resistors 5 and 20, because nakaparallel na silang tulo diri. So ngadto lang ko sa voltage at the 10 ohm resistor, because we all know that the voltage at the 10 ohm resistor by Ohm's law, that is just the current nga mi-pass through sa 10 ohm resistor multiplied by its resistance, that is 10 ohms. So unsa may current nga mi-pass through sa atong 10 ohm resistor class based sa atong result sa Maxwell? Sige daw, unsa man siya? Ang misud diri sa 10 ohm resistor, unsa man nga current? That is unsa man? Base ato nakuha by Maxwell Method. Okay, sakto. I1 minus I2. So therefore, ang current dahil nga misud dira is I1 minus I2 multiplied by the 10 ohm resistor. So here we have I1 85 over 44 minus 15 over 11 times 10 ohms. So ang answer ani to simplify, that is 85 over 44 minus 15 over 11 multiplied by 10. The result is 5.682. So approximately kay point mo siya 5.682 volts. So mo na siya ang voltage nga misulod sa ato ang node AB. Mo na siya, class. And then solving for B, the current daw in the 20 ohm resistor. So kaning last, unsa may pass through ani nga current kana sa 20 ohm resistor? Based sa atong result ni Maxwell, unsa may pass through dira sa 20 ohm resistor? Nana siya sa third loop, I3. Okay, so therefore I of 20 is just equal to I3, which is equal to 5 over 22 amperes. So if kay ka sa Maxwell, dali ra jud kaayo mag-solve sa mga current bisa pag tagsa-tagsaon, bisa pag mayong kag tagsa-tagsa og pangita, makit-an yun. Okay? So nakuha ra? Nasabtan na, class? Nasabtan ra ang kwan? Ha? Walay pangutan na? What if I told you nga kanipod siya makuha niya? So please kan ato dining palita makuan. Ato remember ang voltage at AB, that is 5.682. The current at 20 ohm is equal to 5 over 22 amperes. This is volts. Class, kani siya nga problem, makaya ra ni by manual method. Katong mga branches, dili gamit ni mga Maxwell, ana. Kaya ra kani siya, class. I will show you kung saan. But kung maglibog pa mo adto, ayun lang to i-apply. Kay Maxwell magod na siya, namgo siya system nga gi-follow. Kani siya, bisag wa kay knowledge alamag sa Maxwell method, actually, you can solve it manually. Because this one, this given diagram, it is also equal to this. So, sa ako na siya ibahon og forma nga makakuan mo by using the pinaka old gid nga kuan nga method, katong magamit ta atong mga series parallel nga mga formulas. So here ako dili ana i-branch out din ako, ha. Ako i-branch out, so parallel man siya. So this is the 10 ohm resistor. Next, mi branch out na pod si 5 ohm diri. Branch out si 5 ohm, and then another branch out na pod, nag-usa si 5 ohm og si 20. Then mo combine ni silang duha, and then gi-combine na pod ni sila diri. Then naa na pod si 10 ohm resistor, usa pa mingyad to sa battery balik. So in this case, ma-visualize og tarong, okay? Ma-visualize og tarong ang mga placements og ang type of connections nila. Let's say this is our 10 ohm, this is the 5 ohm, this is the 5, and this is the 20, and this is the 10 ohm resistor, and then this one is the 25 volts battery. Now, what if I'm going to ako pasad ni silang i-kuan, ako bin sila i-compress og tarong. Let's say I'm going to combine these two resistor, and then i-combine na po diri sa ka parallel para kani mahimo na siya ingon ani. Mahimo na siya ingon ani, class. First transformation ato sa itsodaan, dira yan na maana na siya. Then kaning tulo nakaparallel na lang ni sila. Then ana, okay, so here label na punta, this is 10 ohm, this is 5, but here ako nag-i-add kay naka-series man ni siya. So 20 plus 5 is 25. Now, and then this one last is 10. So here, since atong gipangita is ang voltage across this connection kaning naka-parallel voltage dire, voltage AB mao man atong goal. Para makakuha ta na, actually ato pa sa na i-compress para ma-convert nato into an equivalent resistance. Okay? So ang equivalent ana niya ato iubos. So mahimo na sa gingon na single na lang, then ana. Then we have a battery source here. This one is the result of combining these three resistors connected in parallel. So unsa man ka ana, that is the R equivalent here is equal to, that is equal na siya sa 1 over 10 plus 1 over 5 plus 1 over 25. Diba nakakuan mo ni class? Diba mao man ay formula for the for parallel connection, diba? And the equivalent resistance is just the inverse. Diba naka-familiar mo na? Don't worry, nag-record ko sa video last. Okay, so minor na kinaka-familiar mo. So pwede po niyo tanawan. So this one is equivalent to 50 over 11 ohms. So ingon man diri nga ang kuan kita ha, gikan diri inapansin, this is okay, sorry. This one is the node B, this one is the node A. So pag reduce nara pod si B, nara pod diri si A. Pag reduce na pod nara, kita na kayo si B na pod diri si A. Meaning that is just the voltage drop for this new equivalent resistance nga 50 over 11 ohms. And here mas na simplified na because we only have two resistors connected in series. And finding the voltage across BA nga node, very simple na lang. Because we have given 25 volts nga total resistance. Okay? So, para ma-solve nato, we're going to use the formula, itong Ohm's law, that we have V total is equals to VAB plus voltage sa 10 ohm resistor. Diba? But we don't have current here. Okay? We don't have current because if we're going to express this, mahimo pa siyang VAB. Given man ni si V total, dili given si AB, kaya mo itong ipangita. But V10, kaning voltage at this 10 ohm resistor is equal to the current there, I10, times the resistance 10 ohm. But we don't know the current there. But since this is in series connection, so whatever the current that will pass through this resistor is also the same with the total current in this circuit. Okay, parehara. So how are we going to solve for the total current here? Just use the Ohm's law. So that is I total is equal to a voltage total over the R total. And what is the R total? Since this is series, I'll just add this R equivalent by this 10 ohms. Okay, so V total is 25. The total resistance is 10 plus 50 over 11. So we have a current total of 25 over 10 plus 50 over 11. So that is 55 over 32. So we have here 55 over 32 amperes. That would be our I total, which is equal to the I nga mopas sa kanang equivalent nga resistor, which is also equal to I10. So therefore we can substitute that one in our equation. So this would now become, mahimo na siya og V total is equal to VAB plus I total then times 10 ohm. Solving for VAB, so we have VAB is equals to V total minus I total multiplied by 10. So that would be 25 minus the I total is 55 over 32. So right there, 55 over 32 multiplied by 10. So the answer here is 25 minus 55 over 32 multiplied by 10. So the answer here is kano siya? 7.8 7.8125. Wait. Diri. Kani siya. Wait lang. Nasayop din ako pag substitute kay diri sa ubos. So diri 520. So mahimo na siya kanang kuan. 5 times 25. 25 plus 5. So mahimo na siya og 10 times answer. 10 plus the answer. 50 over, sorry, kani siya. Nasayop na kog suwat. Na 50 over 11 manon. This is 50 over 17. 50 over 17 na siya class. Mo nang diri, this is 50 over 17 pod. So nasayop na to. So the I total here pala is 25 10 plus 50 over 17 na siya, di na siya 11 di ay. 85 over 44. Kani siya. This is 85 over 44. So therefore, if that is 85 over 44, so malahi na nato. Malahi ni siya. So mo nang pag-solve magud nako niya, lahi answer dili 5.6 something. Dapat magkapareho na siya. So the result here, 25 minus 85 over 44 times 10. The answer is 5.682. So the voltage here is 5.682 volts. So the same sa atong nakuha ganiha. So naipanguta na? Do you have question, class? Naipangutana ni regarding aning example. Okay, wala na. Okay. So, asa mo prefer? Sa kani, siya, or Maxwell na lang? Asa mo pan class mo prefer? Okay, mas nindot man ni siya or mas kato na lang Maxwell na lang? So ang Maxwell na lang no, kay marag kan straightforward or naagigi follow nga procedure. So since hapit naman ang time, so let's have this last example na lang. Okay. Class, are you still following? Apa mo? Okay. So, do you have any idea on saan ipag-solve? Yung mo siya, find out the equivalent resistance across node A to B. Kasama kay possible buhatan na ni. Nakaagi mo ani sa inyong kan? Sa inyong kan iinga subject. May idea ni? Unsa man ka na pag-answer? idea? Okay, so ingani na siya. Ingani kay ang mga problems, especially in solving for its equivalent resistance. So maglisod gyud mo ani even if you're going to write this tungod aning gi-join manggod tungod aning gi-join kani tungod ra gid ani kani siya because of this 1 ohm resistor gi-join siya sa tunga. So lisod siya, but in order to solve for its equivalent resistance sa may ani nga mga cases class, naay murag crude o pinaka-tricky nga method pod nga mo work gid siya. So here ato i-assume nga mag-connect ang battery niini. Okay, ato i-assume nga mag-connect ang battery niini. So in this diagram ato i-usbon, let's say we have a battery source here, ato gi-connect sa mga node A o B. So let's start with B. So nata din ni ana, then sa middle, and then diri pod, then sa lower ana. So connect na to balik sa battery. So let's say we have here a voltage of E. This is the positive and the negative terminal. This is 1 ohm resistor. So ato ni siya i-red. This is voltage of our battery. This is 1 ohm resistor. This is 1 ohm. This is 1 ohm resistor. This is 5 ohm resistor. This is 3 ohm resistor. So this is our node B. This is our node A. Okay. So here, if we are going to convert this into an equivalent resistor, so ang iya magud aning equivalent diagram would look like this. The equivalent diagram would look like this kana siya. If connected na sa battery ha, mana na siya class. Ana. So this would be our node B and node A, and we're going to label this one as R equivalent. So meaning na usa na tanang mga resistor diri. And if we're going to do that, if maka-achieve pud ta ni ana, this is our E, positive and negative terminal, then this is our equivalent resistance. So naatay usa ra ka current flow diri. That is I. And if we have that, so the expression for the equivalent resistance would be R equivalent is equal to the voltage at the source all over the current nga may pass dira. Okay? E over I. So if we have an expression E over I, that would be the value of our equivalent resistor. Resistance. Mo na itong ipangita. So here, para makaibawatan ni ana is, we're going to use the Maxwell method. So for Maxwell method, ang obvious nga loop nga naa sa tong na-generate nga new diagram is we have 3 loops. The first one is here. Assume na punta. This is my direction. I'm going to label this one as I1. So I1 is just equal to the I here nga atong gi-assume diri, di ba? Mo na siya. So meaning if we can find an expression E over I1, that is just equal to the R equivalent nga atong gipangita. The second loop, assume na po ko that this is the direction for I2 and this is the direction for I3 for the third loop. Since we have 3 unknowns here, possibly 3 equations. So let's start with loop number 1. So at loop 1, Maxwell, misugat siya sa resistor R1. Then for resistor R1, voltage drop, that is negative I1. Okay, 1 raman diri ang resistance. Sa resistor 1 po diri, may interact si I2 at opposite direction. So that is plus I2. The next, si I1 may pass through aning 1 ohm resistor below, closer to node A. Voltage drop na po, so minus I1. May interact po dira si I3 at opposite direction. So that would be positive I3. Next, na may ingagi si I1 nga lain nga resistor. So, may balik na siya sa battery. And pag agi niya sa battery, that is from negative to positive. That is voltage increase. So, we have plus E is equal to 0. So we are going to arrange this in terms of I1, I2, and I3. So we have negative 2I1 plus I2 plus I3 is equal to negative E. Negative E. So this would be our equation 1. Muna siya at loop 1. So again, nganong positive E na dira kay from negative to positive man siya dira ang sa E. So that's why we have positive E. Then next, let's move on to the second loop. So at loop 2, Maxwell na siya ha. Loop 2, natay 5 ohm resistor. So may agi si I2 dira. So voltage drop. So we have negative 5 I2. Next, may agi na po siya sa I1, kaning resistor nga naka-horizontal. So voltage drop minus I2. However, at that resistor pod, may interact pod sa I3. At opposite, so that is plus I3. Then si I2 may labay pod ni I1 sa left side. So voltage drop minus I2. Then si I1 pod may interact pod ni resistor 1 dira. At opposite, so that is plus I1. Kung ano may lain, equal to 0. Rearranging, we have I1 minus 2, pila ka I2, 5, 7. So 7 din siya diri. Minus 7 I2. Then, what else? I3. So that is plus I3 is equal to 0. So this would be our equation 2. So last equation na lang para ma-solve na nato. So here, loop 3 ta. At loop 3, we have si I3 may interact na po aning resistor 1 nga naka-horizontal. So voltage drop na po minus I3. However, at that resistor, ni-interact po si I2 at opposite. So that would be plus I2. The next, may agi na po siya aning resistor 3. Si I3. So again, another voltage drop minus 3 I3 na. Okay, na may value ang resistor equal to 3. Next, may agi na po siya aning kuan. Agi na po siya aning resistor 1 sa left side. Another voltage drop minus I3. Then at that resistor pod, may interact pod si I1 at opposite direction. So that is plus I1 is equal to 0. Rearranging, we have I1. Then I2 here is plus pod, so plus I2. I3 here is 3, 4, and 5. So minus 5 I3 at 3, 4, 5 is equal to 0. So this would be our equation 3. So here, ato is what? But since we're aftering with an expression ha, ato kan is having an expression E over I1. Muna atong gipangita. So in order to solve for that, E over I1, in this 3 equation, we are going to eliminate I3 and I2. Saan pagbuhat niya na? So, mato'y gamit ang method of substitution. So, the first is we're going to combine 1 and 2 and eliminate I3. Okay, so equation 1, negative 2I1 plus I2. Okay, ito yung color para mas ma-visualize o insakto. So we have negative 2I1 plus I2 plus I3 is equals to negative E. Then for the second equation, we have I1 minus 7I2 plus I3 is equal to 0. So here we are going to eliminate I3. To eliminate I3, mag-multiply ko diri. Multiply ko negative sa babaw. Okay? or di na i-multiply, mag-subtract lang ko. So I'm going to take the subtraction para ma-cancel ni si I3. So negative 2 minus 1, so we have here negative 3I1. Then here 1 minus negative ma-positive ni, so ma-change mo yung sign ani, mahimo ning 8 plus 8I2. Here 1 minus 1 ma-0, matangtang na, so we now have equal to negative e minus 0, so that is negative e gihapon. So this would be our new equation, that is 4. So natangtang na dra si I3. Next, tangtangon na pod nato si I3 sa kanang equations 1 and 3 para natay duha ka equation nga in terms of I1 and I2. And in that case, i-combine na pod nato siya again para matangtang si I2, ang mabilin si I1 na lang gyud. So ikaduha nga combination, combine 1 and 3 nga equation and eliminate I3 gihapon. So for equation 1, balik negative 2I1 plus I2 plus I3 is equal to negative e. Then for equation 3, we have I1 plus I2 minus 5I3 is equals to 0. So para ma-cancel ni siya, ma-cancel ang I3, now I'm going to multiply the first equation by 5. Kay 5 man, negative 5 man 3, kung ato yan, ma-cancel na. So this would now become negative 10I1 plus 5I2 plus 5I3 is equals to negative 5e. Isuwat po nimo ang I3, that would be I1 plus I2 minus 5I3 is equals to 0. So adding these two equations, so this would be negative 10 plus 1, so negative 9I1, 5 plus 1 plus 6I2, 5 plus negative 5, 0, then negative 5 plus 0, that is equal to negative 5e. This would be our equation 5. So, na naman tayo duha ka equations nga in terms of I1 and I2 alone, so we can combine them to solve for I1 na lang. So, ika-upat, ika-tulo, combine equation 4 and 5 and eliminate I2. Okay? So, naka-follow pa mo? Are you still following, class? Okay. So, next, ito na isuwat, duha. So, for equation 4, we have negative 3 I1 plus 8 I2 is equal to negative e. And for I5, we have negative 9 I1 plus 6 I2 is equal to negative 5 e. So in order to cancel out this I2, I'm going to multiply equation 2 by 8 over 6. 8 over 6. Nga naman, para may mo na ni siyang negative di ako multiply, para may mo siya 8, negative 8 para makancel ni. So, ang resulta ni ani, ito ni suwat balik. So, we have negative 3I1 plus 8I2 is equals to negative e. Ang second equation, since ang multiply tag negative 8 over 6, mahimon ni siyang positive 72 over 6 I1. Then the second one is minus 8I2 is equal to this one, positive na siya, that is 40 over 6e. Now, adding both equations, say add, this would be cancel out. So what's left is I1 na lang. So ato i-add ni siya 72 over 6 minus 3. The result is 9. Should be 9I1 is equals to kaning 40 over 6 minus 1. The result is 17 over 3. So 17 over 3 E. Since in order to solve for the equivalent resistance, di ba ganiha ingon ko nga makakuha tag expression nga E over I1. So dividing both sides by I1 and 17 over 3, I1 times 17 over 3. Okay, ang resulta makancel ni, so na makancel ni. This would be cancel out. This would be cancel out. So we now have an expression that is E over I1 is equal to kana siyang 9 over 17 over 3. Simplifying, mahimo na siya og 27 over 17. 27 over 17 ohms ang answer niya. And that is also equal to the R equivalent nga ato ang kipangita. So mo na siya ato ang answer for this for this problem. So therefore ang kanaday ko ato na i-combine ni siya kani siya nga figure, ang result nga equivalent resistance niya is 27 over 17. Actually kung na curious gid mo ani, you can construct this kind of kanang kuan iyon ani nga diagram. Kung na may resistor sa inyo, i-connect ni ani din i-read niyo sa multimeter, magawas is roughly 27 over 17. Okay, so ingano yun ang calculation ani. So gamit pud ang atong algebra niini in eliminating unknown variables. So nay pangutana ani. Nay pangutana so far? Awa na?